Hello, good evening. All right. Um, we slightly look at what we learned last week first. So last week we have learned about this resultant force. So for the object that is not moving, up is equal to down. All right. Wait. So for this kind of question, so the R is equal to W. Okay. So So T is equals to mu. Alright, T is equals to friction if the object is not moving. Alright, you need to know this. So for the lift, so if the object is not moving, up and down will be the same. If the object that is moving, so you have to see, right, which way it is moving. So if it is moving upward, so R minus W is equal to MA. Alright, if it is moving downward, so W minus R is equal to MA. Right, if moving up or down with constant velocity, so equilibrium, R is equal to W. Right, this is what we have last week. All right, so so for the pulley system, it is the same. So now they will normally ask you find the acceleration or find the tension. So both. So now you label all the force first. After you label all the force, so this thing it is going upward, up minus down. All right. So T minus 19.62. T minus 19.62 is equal to 2A. So this one is going downward. So the bigger one, 29 minus T. 29 minus T is equal to 3A. So you got the second equation, solve them to get the answer. So you can find A and T. If you want to do it fast, you can, they are asking you about the acceleration only. So you can use this one, bigger minus smaller, right? 29.43 minus 19.62 is equals to total mass 5A. So you can have this. Right? If you want to do it fast, with just find the acceleration only. So if you want to find T, no matter what, you still need to write the equation out. Alright? Alright. Okay, for this kind of question, so you need to label all the force first, right? So this one is going down. So 49 minus T is equal to 5A. Then this T minus friction, right, is equal to 2A. T minus 10 is equal to 2A. Alright, so you can substitute it. Oh, sorry. Here, T minus 10. T minus 10 is equal to 2A. So you solve them, you get the answer. Right? This is what we have for last week. So this week we are going to go for the new subtopic, which is resolution of force. This resolution of force, it is very, very important. Most of the students, they cannot do it well. So now, what I have is I am going to use the way that a simple way, but before this I will explain it to you. But after you know how to do it already, so I will not explain the what's that called, the principle why it is so. Now I explain why it is so first. Now what is resolution of force? Resolution of force is like you got one force here, right? This force is your resultant force, right? So you want to split this force into two directions. So this force, you split it how much to here and how much to here. So one is go to y-axis, the other one go to x-axis. Like for example, you got like 50 Newton. So this 50 Newton is like how much is go to the horizontal 50 Newton force. How much is go to the horizontal and how much you will go to the vertical. All right. So now what I do is, now here you see this is the angle. This angle can be here or here. So now this one, the angle given, it is at here, right? So now I am going to use the triangle to do it. So this is the theta. So this is the force, right? This is the force. Now this is the fx. This is the fy, right? Fx and fy. So now if I am using sine theta, we know sine theta is opposite over hypotenuse. So opposite fy over hypotenuse is your f. So if I time it up, what will we have? So I am having f sine theta. In other words, my fy is equal to f sine theta. Alright. Now, how about if I use cos theta? Alright. Cos theta is equals to, cos theta is adjacent over hypo. So adjacent is my fx over hypo. It is f. I time it up. So f cos theta is my fx. So I rewrite fx is equal to f cos theta. So now if I'm using this triangle, so I'm gonna have fy is f sine theta, fx is f cos theta, which is, now you see here, I am going to use a way that is faster. I say touch or not touching theta. Now if touch, you use cos. Touch, then you use cos. Not touching, then you use sine. Okay, now I want you to have a look into here. This one, this is my theta, right? This is my theta. So this one, this f, if I bring it down, you see it touch the theta or not? Touch the theta or not? I bring to here, become fx. This f, I bring it to here. Touch theta or not? Touch, right? Touch, then I use cos. Right? So fx is equal to f touch theta, f cos theta, f cos theta. So f cos theta. So we can do it very, very fast. Now, you see the theta is at here. So f, I bring to here, become fy. F, I bring to here, become fy. Do I touch this theta? The f, do I touch the theta? No. No. But I still need to use this angle. So I use sine. Not touching, then I use sine. Not touching, then I use sine. Alright. So now f, I bring to here, not touching. I said f sine theta is my fy. F y is my f sine theta. So it will be very, very fast. You don't need to draw a triangle to solve this problem. Okay. Now, if you are still not really sure, never mind. We try to have a look into this example. Now, here, now you got find the normal reaction. So where is the normal reaction? So we need to label all the forces in first. Alright. So now that is two forces acting here. So one, it is called wet. So one, it is called normal reaction. Right. So this is R. This is W. How much is W? 2 kg. 2 times 9.81. So it is equals to 19.62. Now here, if I got a force that 20 here, alright, this 20 come to here. So this 20, it is contributing to Fy and Fx. Right, this 20, sum of the force, it is contribute upward. Sum of the force, it is contribute to the right. Okay, so I hope you know this. Now, then find the normal reaction. So find the normal reaction. Number one. So find the normal reaction. So now there is a force here, right? I want you to know this is a force here, so it contribute upward. So now this force is called Fy. Fy, So how much is Fy? Fy is 20 touch 30 or not touching 30. I want you to see 30 is at here. So 20 touch or not touch 30. Not touching, right? Not touching, then I use sign. So now this object, it is not going upward or it is not going downward. Both, right? Both, it is not going up or down. So R plus this force, right? R plus 20 not touching. I use sign 30, right, is equals to the W 19.62. I repeat one more time. This R is here. I don't know how much. So 20 I bring to here. It is also going up, but 20 sine 30. 20 sine 30 is the one that going downward, right? Is equals to the force that going downward, right? So that I can find the R already. Okay, how much is the R? We use calculator. So 19.62 minus 19.62 minus 20 sine 30 is close to your R, 9.62. Alright, so R is equals to 9.62 Newton. That's all. Okay, is that alright? I repeat one more time because this is first example. I really takut you don't understand. So 20 I bring to here. It is not touching this 30, not touching this 30. 20 sine theta, right? So R plus 20 sine theta is equal to W. R plus 20 sine 30 is equal to theta. So you can get the R from here. Now, the second one is find the acceleration if the frictional force is 2 Newton. So, now here I got one force here, which is frictional force. How much it is? 2 Newton. Right, the question given. Right, this one is 2 Newton. So, now here, this force, the one that contribute to the right, it is Fx. Fx, So, 20, I bring to here. Touch or not touching? Touch 30 or not touching? So touch, right? So the one that pull here will cause the object accelerate into this direction. So F is equal to ma, same. F is equal to ma. So the resultant force is 20. Bring to here, it is 20 cos 30. 20 cos 30 minus the friction. Bigger one minus the smaller one is equal to 2a. So we can find the acceleration how much. So 20 cos 30 minus 2. 20 cos 30 minus 2 equal divided by 2. So the acceleration is 7.66. So we got this. Okay, this is my answer. Now, if I don't use this way to do it, I told you, if I don't use this way to do it, it will be slightly harder. So where you need to draw the force out. All right. So now the way, right, you should do is, if you don't, so now this one will be a triangle. So you need to draw the Fy. This is Fx. Alright. So this is Fx. So how do you do? So R plus Fy is equals to the W 19.62. Right. So where where sine theta is equals to sine 30. I'm sorry, sine 30 is equals to opposite, right? Sine 30 is opposite Fy over hypo 20. So this one go up, Fy is equals to 20 sine 30. And then you substitute into here. So R plus 20 sine 30 is equals to 19.62. You are wasting time. I can use one step. You need to use 1, 2, 3, 4, and then draw triangles some more. So don't waste your time. Right? So use my way. It will be fast. Right? Now, whereas now you want to write the second equation is, oh, okay, here this is Fy, this is Fx. So the one that pull to the right is Fx minus 2 is equals to 2a. So how much is Fx? So Fx is cos 30. Cos 30 is adjacent over hypo. You bring this one up. Fx is equals to 20 cos 30. So you substitute back into here. So 20 cos 30 minus 2 is equals to a. You see, I use one step to do it. Just one step. Right? Okay. So I hope you are okay with here. I repeat one more time. Very, very important. 20, you bring to here, touch this 30, you use cos. 20, you bring upward, not touching, you use sine. Okay, sine this angle. Now, okay, of course, some students will ask me, Cikgu, this one is 90 degree, right? This one is 90 degree, yeah? So this one is 90 degree, meaning that this one is 90 degree, yeah? This one is 30, meaning this one is 60, right? Yes. Okay. Now, why not? Why not? I try. So, 20, I bring to here, touch 60 or not? Touch 60, right? Yes. Touch 60, then I use cos. Can or not? Can. But normally we will not do it that way, lah. It can be that way. So 20 R plus 20 cos 60 touch 60, right, is equals to W 19.62. Teacher, this one different. No, the one that you do, it is different. Never mind, we try to press in the calculator, see whether it is the same or not. So what we have is 19.62, right, minus 20 cos 60 equal to 9.62. Yeah, same thing. Right, you no need to worry, it is the same. For those who come in late, you try to follow, right, because you don't know what is the one that I'm saying, that what is touching, what's not touching. So you better follow. If not, you drag to the front from the very, very beginning, and then you start to watch from there. If not, you don't get it later. Okay, now we look at the next example. So find the normal reaction and acceleration of the object. So that is two forces acting into this object. So one, it is reaction, the other one is weight, right? So this is R, this is W. W is equals to 2 times 9.81 is 19.62, right? 2 times 9.81, so I don't do here, I don't show it out here. So now you got one force of 20, it is pulling this way, right? So now you are going to find normal reaction. So the force that going up, so I'm going to write the first equation. So up, the force going upward is here, this one, and 20 contribute to here, right? So R plus 20, touch or not touching? Touch or not touching 45? 45 is it here? 45, 45 is at here. So 20, I bring to here. Touch or not touching 45. Not touching 45, then I use sign. Sorry. Touch, then I use cos. Not touching, then I use sign. You need to memorize it. Right? Not touching, I use sine 45. Right? Is equals to 19.62. So how much is R? R is minus so I got 5.47 at 5.47 at Newton. Right? So number two. Now, because of I am pulling here, right? I am pulling here. This 20, there is some force contribute to here, right? So I said this 20, I can resolute some force into this direction. 20, touch or not touch 45. 20, touch or not touch 45. 20, touch or not touch this 45. Touch, right? 20, touch 45, so cos 45. So 20 cos 45 minus the friction. How much is the friction? Friction is 2. So I can find the acceleration here. 20 cos 45 minus 2. Divided by 2. So 6.07. A is equal to 6.07 ms negative 2. Okay, this is what we have. I repeat one more time. 20 touch 45 minus the friction. I forgot to label the friction. The friction here, it is 2 Newton. Right. 20 cos 45 minus 2 is equal to MA, 2A. Right? 20 cos 45 minus 2 is equal to 2A. So you can find the acceleration already. Alright. I hope you are okay with here. If you cannot, let me know. Let me know. I will reteach again. Okay. Let me know if you don't understand. So the first one, find the normal reaction and then find the acceleration of the object. So now there is one force going down that is called weight. How much it is? 19.62. So there is a reaction. There is a normal here. Normal is always 90 degrees to the surface, right? So now here, this is the surface. This is the surface at here, right? Always 90 degrees to the surface, right? So here, just now, teacher, this one is going up. Oh, yeah. This one is, the surface is at here. Your reaction is 90 degrees to the surface, right? Always 90 degrees to the surface, yeah? Okay, so after you label it already, so you need to know here that is a, here, this angle, how much? This angle always equivalent to this angle, always, right? I explained to you why already previously, so I am not going to explain right now. So this one must be equal to this angle. Must be equal to this angle. Okay, so now what I have is, now this object, if it is moving, where will it move? So it cannot move into this direction one. It cannot move into this direction. So it only can move into this direction, right? Up or down. If I pull it, then it will go up. If I let go, it probably will stay there or it will go down, right? So what we have is, and down is always the same, right? So how much is R? So now we are going to find how much is R. Number one, R is equals to 19.62. 19.62. Now I want to ask you, this W I bring to here, touch 30 or not? Touch the angle 30 or not? Touch 30 or not? Yes, right. Then we use cos. Cos 30. Alright. So R is equal to 19.62. 19.62 cos 30. So I'll get 17 lah. Round off. Right, 17, 16.99, about 17 lah. I round off, just round off. Right. So number 2. Now here, this one, this force 19.62, this weight, it is contributing down here, right? So here there is some reaction, right? So some reaction here, right? So reaction how much? Smooth surface, no reaction here, no reaction. Smooth surface, no reaction. So another word is, now here, this force contribute to here, how much? Minus here is your acceleration, right? So F is equal to ma. So 19.62 I bring to here. Now when I bring to here, now touch or not touch 30. Here, touch or not touch 30. Here, touch or not touch 30. So you tell me, Cikgu ne, touch this 30 ne, they're black 30. No. I mean this 30, not this 30. No. Right? So this anchor must, the anchor that you use must be anchor. So where is the anchor? Anchor is at here. At here. Touch this theta or not. Not this one. This one is out of the topic already. Not there. Nothing to do with this 30 here. So now the one that you should see is this one or this one only. The angle of here. So not touching 30, then I use sine. Right? So 19.62 sine 30 minus the friction. Friction. So wait, one more time. 19.62 cos 30, bring to here already, minus the friction. Minus 0. No friction, smooth surface. Right? Minus 0 is equals to MA 2A. So 19.62 sine 30 divided by 2. You get 4.905. Okay. I hope you are okay with here. Now, I try. I know I should not use it. So now some of you ask me, Cikgu, this one is like this one 30. This one is 90, right? 90 minus 30, here it is 60. Alright. So the force that going here, it is Fy, right? We call it Fx. This one Fy. Fx. So this one is Fy. So now here, this force is touching 60, right? So 19.62 cos 60, touch 60. When this force, the force here, this force, I bring to here, touch 60. You see, I touch this 60, right? Minus 0 is equals to 2A. Yeah, can. A is 19.62 cos 30 divided by 2. 19.62 cos 60 you get back to the same thing. Alright. So no matter you use sine or you use cos, as long as you use the way that I taught you, then you can do it. Alright, you can use it fast. Now I try to do one more time without using my method that I touch. Teacher, I don't know what is cos, what is sine. Okay, then you follow your teacher one. Right, you don't want to use the easier one. So another word. So I am going to draw this. I'm going to draw this. Please don't learn this. I don't like you to do it. So this is W. 19.62. So this is R. This is R into this direction. So this one, I don't know. Right. So this one. So that is a resultant force here. This one is in this resultant force. So this angle is 30. This angle is 30. Okay. So this one will cause you an acceleration, right? This way will cause you an acceleration. So now sine 30 is equals to opposite over hypo, right? So this one is a F force, right? Hypo 19.62, right? So now this object is, this one is force. Force is equal to MA. So this one go up is 19.62 sine 30 is equals to 2A. 19.62 sine 30 is equals to 2A. If you, this question is no friction yet, if got friction, then it will be more complicated. Now, here, now how about cos 30 is equals to adjacent over hypo, R over 19.62. So this one go up is R is equals to 19.62 cos 30. Why I use one step to get the answer? You need to draw it out, and then you need to think, and then you need to sign opposite, adjacent, hypo, blah, 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 and then get the answer. Why? Don't use it. All right, don't use it. I told you already. Use my method faster. Now here, example 25. So I am going to use a force here downward. This is called weight. This is reaction going upward. Here, this is R. This is W, 19.62, 2 kg. Alright, so now that is a force. This is the angle. Alright, this angle is 30. I label it in first. So now this one got friction. So this object is going to slide down to the inclined plane here. So there is a friction. How much is this friction? 2 Newton. Now, this question not asking me the R, so I don't want to do the R. R is equal to 19.62 cos. So I don't want. So I want to find the acceleration only. So I am going to do this way, right? So my resultant force F is equal to MA. Okay, F is MA. So now this force 19.62 bring to here, touch 30 or not touching 30. 19.62 bring to here is the force that pulled it down. And then you got one force pulled it upward. It is the friction. 19.62 cos or sine 30. 19.62 touch 30 or not touching 30. Not touching 30, right? Not touching 30, I use sine. Not touching, I use sine. 19.62 sine 30 minus 2 is equals to MA, 2A. So I can find the A. 19.62 sine 30 . minus 2 equal, divided by 2 equal. So 3.905. Okay, I get the answer. Very straightforward, very, very fast. Okay, is that okay for you? Okay, I hope you're okay. Now we continue from here. This is the weight, 5 kg. This is a reaction. And then this is the anchor that I want to label later. Now 5 kg is 5 times 9.81, it is 49.05. 49.05. Okay, this is the error. So this angle I put it in, this angle is 45 degree. Okay, so I put in all the information already. Now what they are asking me, normal reaction how much? Okay, now if they want to find the normal reaction, so this normal reaction is equals to W, right? I bring to here, right? This W 49.05, touch or not touch 45, touch or not touch 45, touch, right? Touch, I use cos, right? Number one, R is equals to 49.05 cos 45. So how much should I get? Time cos 45. 34.68. Okay, so I found the error already, 34.68. Now I want to see the acceleration of the object. This one, it is going to accelerate downward, right? Because you put it to here, so there is some friction here, right? If they got friction, if no friction, they will say this is smooth surface, right? This friction, it is fine. So I'm going to label it in this one. The friction here, it is 5 Newton. Right, friction. So now the force that pulled it down is this one contribute to here. I resolute it to here. 49. So touch or not touching 45. This is a 45 here. Touch or not touching. Not touching, then I use sine. Okay. So 49. So the force that bring it down is 49.05 sine 30. It's 45. Sine 45. I'm sorry. Not touching 45. One more time. So this 49.05 I bring to here, not touching 45, right? Minus the friction, minus 5. 5A. 49.05 sine 45 minus 5 equal divided by 5. I get 5.94. 5.94. Okay, I'll get 5.94. Is that okay for you? Alright, I hope you understand it. Now we go to 1.3. So 1.3, forces in equilibrium, right? Equilibrium net force is equal to 0. How do we know the theta is 45 degree? This one is 45, so this one is 45. Always the same. This angle is 45. This one is 45. Now, no matter what. Alright. So, never mind. I calculate for you. Never mind. This one is 45, right? So, this one is 90 degree. The weight is going down. This one is 90 degree. Right? 180 minus 90 minus 45. This one is left 45. This one 45. This one is 90. 90 minus 45. My 90 here minus 45. This one will be 45. Always the same one. Always. Alright, for example, this one. Alright. This one is 30. Yeah? This is 30. So this one is 90. 180 minus 90. How much? Left 60. Right? 180 minus 90 minus 30 left 60. So this one is 90. 90 minus 60. So this one gonna be 30. So this angle is always same as this angle. This angle is always same as this angle. No why. Always the same. Always. Right? If this one is 20, then this one 20. This one 30, this one 30. This one 45, this one 45. This one 50, this one 50. Right? Always the same one. Okay? I because of I do explain it a little bit here. Right here. When I said this angle always the same. Oh, I didn't explain. This one is the one when I am teaching here, I slightly explain this angle and this angle, it is the same. So, oh, this angle I didn't label. Oh, the other class I tell them. I tell them it is the same. This one, this angle is always same as this angle. Always the same. Alright. So R is equal to W touch cos 30. If this one is moving with constant velocity, up and down will be the same. So the force that moving downward is W. I don't touch theta. Sine. W sine 30 is equal to friction. W sine 30, this one is equal to friction. If bigger, so W sine 30, right, minus friction is equal to MA. The calculation. This one, no calculation. I just tell you the situation. Now, we do calculation. Alright. Okay, we continue. This one even more complicated. Alright. So equilibrium resultant force is equal to 0. The object is either at rest or moving with constant velocity. So now this one, the question asks you find the tension of each rope and draw the triangle force. They want you to draw the triangle of forces. Now, alright. So now here that is a force. Here that is another force here. Right. So I call it as T1 and T2. Tension 1 and tension 2 because it is a rope. So we call it a tension 1 and tension 2. Up to you which one do you want. Right. So now here I am going to see I draw this one so that it's easier for me to see. So Z here it is 30. Right, this angle it is 30. So I got everything in already. So now I want to find the tension of each rope. So this object it is equilibrium. So if it is not equilibrium, then it will start to move down or it will slide go to the left or right. So they will ask you acceleration. So if they find the tension, surely it must be in equilibrium. Must be not moving one. Alright? So the force that going left is equal to the force that going to the right. The force that going upward is equal to the force that going downward. Alright? So downward, that is a force that I forgot to label. It is weight. How much is the weight? So 4 times 9.81. It is 39.24. Right. So I got everything in already. Yeah. Now the force that going to the left, it is T1. T1. Right. The force that going to the left is T1 is equals to T2. Now, this T2, it is not going to the right, not going to the right, chun. So this one is going to this way. So I need to T2, I need to bring to here, touch or not touching 30, right? This one bring to here, touch or not touching 30. So touch 30, right? Touch is 30, yeah. All right, touch, then I use cos. T2 cos 30. So I got the first equation. This one left and right. Right. So now I want to see the force that go up and down. Right. Now the force that this one got two unknown, cannot do. Got T1 and T2, cannot do. So now this force I am going to bring it up. This force is go to the left only, so it is not contribute anything to upward. So this one no need. So now the second force is T2. I bring up to here. Right. Touch 30 or not touching 30. Touch 30 or not touching 30. T2 I bring to here, not touching this 30. Not touching, I use sine. Right. T2 sine 30 is equal to my weight, 39.24. Right. So I can find T2 already. T2 is 39.24 divided by sine 30. So you got 78.48. So I can find the T2 already, 78.48 here. So after that, I find T1. Right? I substitute this one into here. So T1 gonna be right. T1 gonna be 39.24 divided by T1. Sorry, T1 is 78. T2 is 78. 78.48 cos 30. Right? You time cos 30. So 67.97 unit Newton. So I found it. Alright, both. Alright, you substitute back this one. You substitute back this one into. You substitute back this one into here. T2. T2 then you get the answer. Alright. Okay. I hope you can understand here. Alright, so we continue. So now this kind of question, I am going to put in the angle here. This one is 30. Here is 30. So both 30 here. Okay. Now here, that is a force that pulling upwards. So now this one is T. This one also T. Okay, now of course you ask me, Jegu, isn't it this one is T1, T2? Yeah, up to you. Now, because of this angle and this angle, it is the same. Right? This angle, it is the same. So this tension and this tension, it is the same. I repeat one more time. This angle, when it is the same, so the tension will be the same. So you no need to put T1 and T2. If you want to put it as T1 and T2, yeah, up to you. Yeah, okay. No problem. So when this one, the angle it is the same, the tension of the rod will be the same. If this one it is not the same, then the tension will be T1 and T2. One of them are bigger, one of them are smaller. Okay. Now, here, there is another force that going downward, right? So this is the weight, right? The weight is going downward, 49.05. 5 kg, huh? Alright, so now the force to the left is equal to force to the right. So we don't need to calculate. If I calculate, it will be this way, right? T cos 30 to the left, where? T cos 30 here is equal to T cos 30 here. Touch 30, ah. So, you cannot do. You divide T is equal to T. Cannot. You cancel the T, cancel. So, this one just tell you the force here and here it is the same. This T is equal to T. So, if you are using T1, just now T1, T2, so you set T1 is equal to T2. You do it, you will get you T1 is equal to T2. Mean tension, it is the same. You do it, it will be the same. Alright? So I leave it here. I don't want to do anything from here. So here. Now, the force that going upward. The force that going upward is here. I bring to here. And here, I bring to here. So this one is T touch 30 or not touching 30. This one is T touch 30 or not touching 30. Right? Not touching, right? Not touching, are you sign? Not touching, that are you sign? So T sine 30 is from left hand side one. So this one I bring to up and then plus. This one I bring upward. It's also weight. The weight is 49.05. Because of this object is equilibrium. Right? 49.05. Sorry, I forgot to draw the triangle. But never mind, I draw the triangle one go later. If I forgot, please remind me. So after I finish this 4 example first, right? So we do it. We draw the triangle later. So now this T, right? So you can have. What do we have is T I factorize out. So you got sine 30 plus sine 30. Sine 30 plus sine 30, it is 1. Right, sine 30 is 0.5. Sine 30, how much it is? 0.5. 0.5 plus 0.5, it is 1. 1 times T, still T. So, T is equal to 49.05. Right, that's all. So, I found T already. So, this T already, this T, it is the same. So, T and T, it is the same. So, it is 49.05. That's all. I draw the triangle later, I tell you. Okay, we are going to do this kind of question. So this is T1, T2. I like to put here, left hand side is smaller number, T1. Here, T2. So it is really up to you. Okay, so this one is T1. Here it is T2. And then this angle, I'm going to put it in this angle. This angle is 20 degree. Here, this angle is same as this angle, Z, Z, Z. This is 40 degree. And this angle is 40. And then you still got one more weight. W is equal to mg. 6 times 9.81. How much it is? 58.86. Okay, so I label all the forces in already. So now this one more complicated because of the angle, it is not the same. So T1 touch or not touching 30. I bring to here. Left hand side. This one go to the right. T2 I bring to here. Touch or not touch 40. Touch, right? Touch, I use cos. Right? So T1 T T T1 cos 20 is equals to T2. Right? Cos 40. I repeat, T1 cos 20 is equals to T2 cos 40. Right? This T1 and T2 different. Only when the angle it is the same, then it will be the same. If the angle different, so the tension will be different. Right? Tension will be different. Right? So now this one unknown. So I am going to leave the T1 here. T1. I said 1 is equals to T2 cos 40 divided by T2 cos 40 divided by cos 20. I repeat one more time. See here, this one you can do it later if you don't want to do it first, but later you still need to do it one because that is too unknown. You leave the T1 here, it is easier for you to substitute later. So this T2 is left here, so I divide by 20, cos 20 down. So I divide by cos 20 downward here. Right? T2 cos 40 divided by cos 20. Right? So this one I am going to leave it as 1. The first equation. Now I want to do the second equation. So how to write the second equation? So T1 here I bring upward. T2 here I bring upward. Total the force going upward is equals to the total force that going downward. Up and down will be the same. So up and down will be the same. So the up force is T1 touch 20 or not touching 20. Now you need to see here. Touch 20 or not touching 20. I bring to here. Touch 20 or not touching 20. T1 I bring to here. Not touching 20, right? Not touching, you sign, right? So T1 plus T2 T1 plus T2 sine 40, right? Where is the sine 40 come from? This one here, 40 you bring to here. This T2 you bring to here. Also not touching 40. You don't tell me touch this one black one, the black one useless. The one that I mentioned is this one, right? The one that I want you to see is touching this one or not, right? Not touching, I use sine, right? Sine 40 is equals to the weight that going downward, 58.86. So this one cannot do. You got one unknown, you got two unknown, cannot do, right? So this is the second equation. So now you are going to substitute this one T1 into here, right? Substitute this one into here, right? So if I substitute, what will I have? I do it here so that I can see, right? So that I can see. So now T1 is T2 cos 40. T2 cos 40. T2 cos 40 divided by cos 20. right? Cos 20, so this one is T1, time sine 20. T1 is this one, right? This one. And then sine 20, I just copy down, plus T2. T2 sine 40 is equal to 58.86. Alright, I substitute it in already. Now, what I do is I got T2. I factorize the T2. Right? So, now my T2 will be equivalent to so now I don't want to rewrite here, so I should write one is T2 then cos 40 divided by cos 20 sine 20 plus sine 40 is equal to 58.86. So this whole thing, when I press into the calculator already, then I divide down, it will get my T2, right? So I'm going to press in the calculator. So I will advise you to press this one first. Don't press 58.86 divided by this one. So cos 40. Some of your calculator need to press cos 40 and then cross bracket some more, right? So you check properly your calculator. Some of your calculator you need to cross bracket. So not very good to use, but what to do? So divide. I seldom use over. I don't like to use over. I use divide. Right? Cos 20 times sine 20 and then plus sine 40. Sine 40. Okay? So this one. So this one is your answer for this one. So 58.86 divided by answer. So you get 63.87. That's my answer. 63.87. Right? But after you find the T2, T1 you need to go back to here. You need to find T1. So T1 is T2, T2. This one is T2 time cos 30. So I time cos 40. Sorry, cos 40 divided by cos 20 is my answer. 52.06. Yeah. You just substitute this one into here back. So if you want to write from one T1 is blah, 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 you go ahead to do it lah. So I don't do it lah. So this one is simple one. Okay. So we are going to rest for 5 minutes. Right, 5 minutes after 5 to 10 minutes lah. After 5 and 10 minutes, we go back to do this. So if you want, you can try to do this on your own. Right? You try to do this example 30 on your own. So if wrong, later I will discuss. Right? I'll see you later. I'll see you back later. Huh? Teacher, actually easier to calculate drawing triangle of force. Yeah, up to you. You want to use the triangle of force, it is easy. You think it is easy, then you go ahead. For me, I think this way it is easier. Right? If you want to use a triangle, then use triangle. Sometimes they will ask you to draw with the triangle. Triangle first, and then use a triangle to calculate. Okay. Right? So I am going to do this. So here, that is a force tension. This is a force tension. This tension both are the same because of the angle, it is the same. So that is a weight going downward. So find the tension of the rod if the picture frame it is 7.5 kg. So W is 7.5 times 9.81. It is 73.575. All right. So now we are going to calculate here. So the force going to the left, the force that going to the left is this force, right? This T cos 40 is equal to T cos 40. So it is the same. So no need to do. So we need to do the one that going upward. And this one going upward is equal to the force that going downward. The force that going upward is T not touching 40, right? Sine 40 plus T sine 40 is equals to 73.575. So T you factorize out, left sine 40 plus sine 40. So sine 40 plus sine 40 is right divided by sine 40 plus sine 40, right? Okay, so I'll get 57.23. Okay, this is the answer, right? So you see, I do 2 steps only get the answer. If you want to use triangle, never mind. I'll do the triangle later. Is that okay? Yeah. If it is okay, so I am going to draw the triangle right now. Okay, I'm going to draw the triangle right now. So now they ask you to draw the this question not asking you lah, but I want to do it. Okay, so now you can start anyone. All right, you want to start from here or here or here. So make sure you go back to the same point. All right. So now this is W. This is W. And then this is T. And then this is T. This is this T. And then this is this T. And then this is W. So I label first. Right, the direction must be inner. Right. So this is T. No, sorry. This is W. This is T. This is T. Okay. You said it is easier, huh? I show you, Okay. Now you want to calculate T and W. So this is the angle, right? This is 40, right? To the horizontal, here it is 40, right? So this angle is 40, right? How about this angle, this angle, this angle and this angle, it is the same. So here it is 40 degree. All right. So this is W. W is 73.75. So now let's say you don't do this. You see, I use one step, two step to get the answer, right? But now I use triangle to do it. So how to do? This one, I just draw the triangle only. But if I want to calculate, right? So here, this one is 90, right? So this is 40. So this one is 50, right? So now, I use a triangle here to do it. Here is 40. So this is W. Whole thing is W. This is half of the W. Half of the W. So T, this is T. T. So sine 40 is equals to opposite. Opposite is half of the W over the T. Right? Am I right? Half of the W times T. So this one go up. T sine 40 is equals to half of the W. W is this one. So T is, where got easier? I think it is harder, right? You need to draw this, and then you need to write this, and then you, but never mind, you get used to it. Okay, go ahead. Half, 1/2, 1/2. Sine root also can. Yeah, sine root also can. Up to you. So I can use sine rule, no problem, right? You can use sine rule, you can use cos rule, you can use whatever rule. So I use this one, Pythagoras theorem. Yeah, okay. 73. They come from the same. They come from the same principle one. Divided by sine 40. Right, that's my answer. Right, 57.23. Right, so answer is 57.23. Okay. So this one easier or this one easier? What do you think? I tell you why I am teaching you this one. You see if I don't have it already. A few years ago, my student, she go to Form 6, and then her teacher using triangle to teach her, and then she get used to my way already. So, and then she still come back to ask me, teacher, how to do this question. So for example, the question like this, the question are very complicated one. Like that. Okay. So this is 20 Newton, 30 Newton, 40 Newton, 15 Newton, 50 kg, 500 Newton. This is 30 Newton. And then how to do this? So now the force that going, the anchor put in. So this force bring to here, this force bring to here, this force bring to here. More than one force, then triangle cannot do it already. So you have to use my way. So if you got 3 force or 4 forces acting on the object, so you cannot do already. So you have to use my method. You get what I mean? This way. Okay. But for this one triangle, 3 forces, okay. So we go back to here. Find the tension on the rod and then draw the triangle of forces. Right? Draw the triangle. So now I am going to draw. So T1 and W and then T2. So I like to use W first. W go down and then T2 and then T1. Right? So label the direction, then it will be okay. Right? So here it is T1 and then here it is T2. T2 into this direction, and then W is this going downward. Now, still got another way to draw it, alright? So, which is Teacher, I go W first and then I go T1. And then lastly I go T2. Yeah, T2. Is this okay? Yes, okay. Same. Now, if I use it, put it back to here, it will be the same, right? They are the same thing, right? So you draw one is enough. You don't need to draw two. And then, now most of the students get misunderstand with this triangle. Now, teacher, previously you said T1, T2, and then T1. And this one go to here, this one go to here. It is supposed to be here to here, right? But your W, it is going down. Salah lah. Oh. T2 and then T1 is supposed to go up leh. From here, start move, come to here, and then it's supposed to go up. Teacher, why yours one is going downward? Alright. Now, yeah, what you say is true, but yours one is not equilibrium. So this kind of question, not moving, then it will be equilibrium. So what do I say is this one? Let me see. Let me see. Like this kind of question. I find another one for you. Okay. Now, teacher, the one that you teach previously, it is different. Okay. So the one that you come to here and then come to here is supposed to come to here. Right? So this one, it is resultant force. Sum of the force, resultant force. This one is not equilibrium. Okay? You force come to here, and then it's from here to here. It is not going to go back. Now, the force that in equilibrium is, right? This one equilibrium is, now you see the force, you turn one round. So from here to here. So it go in one round. Not like you go to here, it's from here to here. No. You get what I mean? So this one is equilibrium. That one is resultant force. Alright. I hope you're okay. So I draw this. I try to use your way to calculate. So you are, when you have drawn this already, so you need to label the angle. Right? This is the angle T2. So this angle is 30. Right? T2 is 30. So this one is 39.24. Right? 39.24. Wait. Now sine is opposite over hypo. Right? Sine 30 is equal to opposite. Opposite is 39.24 over hypo. Hypo is T2. Right? This one go up, this one go down. Right? So T2 is 39.24. 39.24 divided by sine 30. Okay, you got T2 is 78.48, right? T2 is 78.48, right? How about T1? T1 is, now, cos 30 is equals to adjacent over hypo T2, right? So 78.48, right? So now you bring this one up, is time cos 30. So I get 67.96. 67.96. You get back to the same thing, right? Now, so now you see, I have one step, 2, 3, 4. 1, 2, 3, 4. Which one faster? You still need to draw this. I don't need. I don't need. My one is faster, I tell you. You follow my way will be faster. But if you get used to your school teacher taught you this one already, you get used to the way of this one, then you go ahead. No need to worry. Same thing. right? So, uh, so this one, we are going to do this one. So this one, W first, and then T, and then T, right? So we label, this is W, this is T, this is T. The direction have to be correct. So the direction is W going downward, right? T going this way, T going this way, and T going this way, right? If the angle they want, so you label in the angle. So this one is 30. So meaning that here it is 30. Here is 30 zigzag. Here it is 30. This one 30 means this one also 30. This one 30, yeah. This angle is here. Same, 30 zigzag 30. Meaning that this angle it is 60 if you want, right? If they ask you, so you put it in 60. You want to use cos rule, sine rule, or Pythagoras theorem, it is okay. No problem. Okay? So another one will be this way, right? Another answer will be this way. So this is T. This is T. Right? This T, same as this T. Meaning that this one is here, 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 here. You see? It go in one round. This one, it go in one round. Go in one round. Right? It will come back. So when it go back in one circle, one circular, it will be called equilibrium. Okay. Now this one I draw it here. This question also asking me to draw. So now T1 here. Oh, I always start with W first. W and then T2 and then T1. So this is W. This is this direction. This direction is T1. This direction is T2. This angle I want to put it in. This angle. So this angle is T2. Right? T2. For the T2 to the horizontal, T2 to horizontal, it is 40. Okay. Now, from T1 to horizontal is 20. T1 to horizontal is 20. This 20, Z is, this one is 40. So altogether, it is 60. So if you want, you put it in. This angle, it is 60. Okay, that's all. Right, 60. So this one is, I forgot how much. Because of this angle and this angle is not the same, so I need to put it in. So this is 40. Yeah, 40. So meaning that this one is 50. Here 40, yeah? 40. 90 minus 40, it is 50. 50, 60, 70. Put it in. All right. Is that okay? So now we try to do some question together. Okay. Now how to do this question? So diagram 13 shows a flower pot with 2 kg hanging at the pole. Calculate the tension of each rope. So now T bring up is equal to W, right? So T, this 30 Z. So what do we have is this angle is 30. Okay, the tension will be same. So up is equal to down. So what do we have is T touch 30 or not touching 30, I bring upward. T, I bring upward. Plus T, I bring upward. Is equal to the force that going down. Not touching, I use sine. Alright. T sine 30 plus T sine 30 is equals to my weight, 2 mg, 2 times 9.81. Okay, you know sine 30 is 0.5, 0.5. So T is 2 times 9.81. 2 times 9.81, right? It is about 20, right? This one, they use the gravity as 10, right? Never mind. I'm afraid that you don't understand. Sine 30. So sine 30 plus sine 30, you press in the calculator, you get 1. Sine 30 plus sine 30, you get 1. 1. So T times 1 is 19.62. So T is equals to 19.62. So if you round off, it will be 20. Alright, so we put the answer as 20. Okay. So we continue. Now, diagram shows the object is equilibrium. Equilibrium, so you see, when equilibrium, it must be go in one round. Okay, yeah, go in one round. Cannot. Cannot. This one is not equilibrium. Alright, so very easy to identify them. So, not equilibrium. This one, the arrow, you see? So only this one is equilibrium, but I don't know whether this one is the answer or not. So we see J, yeah, J. You see W, L, yeah, W, L, yeah, K, yeah. Okay, answer is A, equilibrium. These three, it is not in equilibrium. All right. Diagram shows the man is pulling the object. So the frictional force is 4 Newton. All right. Where is the frictional force here? All right. So what is the horizontal resultant force? Horizontal resultant force is 50, bring to here. Touch or not touch? Touch. Touch 40. So cos 40. So the horizontal resultant force is 50 cos 40 minus 4. The resultant force only. So no need to calculate acceleration. They don't ask you. So this one is 50 cos 40 minus 4. Answer. 50 cos 40 go to the horizontal minus the one that pulling you. Right? 50 cos 40 minus 4. 34.3. 34.3. Now, very fast. If you use triangle, it will be very, very hard to do, isn't it? You try, if you try to use triangle, see whether you hard or not. You believe in me. use triangle? Huh. I guess you need longer time from here. I use touch or not touch, and I can get the answer already. Alright. Which of the following it is equilibrium? So equilibrium must be not moving or moving with constant velocity. Right? A picture frame is hanging on the wall, not moving, right? Yeah. You are the answer. So a coconut falling, you are moving. Moving with acceleration, no. So taking off from the runway, you are accelerating. Right? The airplane, it is moving with acceleration, no. Sailing in the sea, you got the acceleration maybe. So maybe you stay with constant velocity, but I don't know. But this one is not moving. So answer is A. So which of the phenomena experience the equilibrium? So thing that accelerate, no. Floating at rest, yeah. Falling down with the acceleration, no. Right? They don't say acceleration, but when you fall down, must be acceleration. Which of the following it is vector sum of 3 Newton. Vector sum mean it is not equilibrium. I purposely put it into here. It is not equilibrium. Teacher, why this one like, why like this one, cannot go back one. They never said equilibrium. Cannot. Teacher cannot one. None of them can. This one equilibrium. But this one is vector sum. Vector sum mean you got 3 force, 3 Newton. You got 4 Newton. So where will it go? It will go into this direction. Whereas 3, 4, right? 3, and then 4, 4, 4, and then 3, and then it is equivalent to this. Another word, so I pull here 4, you pull here 3, is equivalent to here? Yes, correct. Answer is A. Now, you pull here, I pull here, so it's supposed to go to here. You pull here, I pull here, it is not going down. No. This one equilibrium, but it is not vector sum. So answer is A. This one you pull here, then you move down. So it's supposed to go to here, not this direction. So answer is A. How? Diagram 13 shows the method to determine the resultant force of two forces by using the triangle method, right? So which of the resultant force? It is not equilibrium. Result of the force. So you pull here, I pull here. It's supposed to come to here. The answer, right? You check. You see when I see the answer. So go into this direction. Go into this direction. Go into this direction. So this one got chance. This one got chance. This one also got chance. But the x is going to the right. X is going to the x is going this way. X is going this way. Yeah. This one okay. X is going up. No. Where got x is going up? X is going this way. X is going this way. No. So answer is C. Alright. So you see when I do this, I'll set y. Y correct. Y correct. Y salah. The direction wrong. So x okay correct. Right. This is x is correct. So now this one is x. Salah. So this is the y. This is a y. This is a x. This is a x. So these both are okay. But this one is not equilibrium. Cannot go back one. Right. So this one like this resultant force is wrong. This one also not equilibrium, but this resultant force is wrong. When you draw the parallelogram, you see when you pull here, I pull here, it will come to this direction. You come into this direction. How can it come from? Where is this one come from? No way. This one the direction is wrong. So answer is C. Alright. So equilibrium, speeding up, no, right? Moving with uniform velocity, yes, uniform velocity, right? A car moving around roundabout. I don't know whether got acceleration. This one got acceleration. Taking off got acceleration. Yeah. So we try to do this. Determine the triangle of force which is correct in the equilibrium of all of the force. They said equilibrium, so must be turned back one. So T2, the direction must be into here. They don't draw, you also need to know. Right? T2 is go to here. T2 going down wrong. Going down wrong. Going down wrong. Going up only this one. How about T1? T1. And then how about W? W? Yeah, B. Right? Answer is B. Is that okay? Alright. The diagram shows the boy weight is 200. Okay, weight is 200. Mm. 200 Newton. Weight 200 Newton. That is sliding down at an angle of 30 here with the frictional force. Frictional force is the way that it against the motion. So it is 20. Right. Now you see now I use the triangle method to do it. it will be now sliding down, W 200, right? Oh, sorry, I forgot to label my 30 degree. 30 is here. 30. Okay. So I label already. So now they said which one it is correct when it's moving downward. W 200 bring to here. Touch 30 or not touch 30? No, right? I use sign. 200 sine 30 minus 20. 200 sine 30 minus 20. 200 sine 30. You see, I straight away get the answer. Answer is B. Very fast. Do you get it? I repeat, 200 I bring to here. Not touching, I use sine. 200 sine 30 minus 20 is equals to MA. So this is my resultant force or net force. We can call it net force or resultant force. Okay, we continue. Now, diagram 17 shows a man pulling a bag. The bag is moving horizontal even though the force applied it is angle value theta. So what is the name of the process of single force splitting into the two perpendicular force? So this one is called resolution of force. You split into two directions, which is 90 degree. Okay. Now, the diagram 18 shows the three forces PQR, right, hanging here. So now this one hanging stationary must be equilibrium. So the one that you see letter must be equilibrium. So we start from P. Let's say P. P is going this way. P is going this way. Okay. P. Salah. P salah already. P. P way got going down. Salah. P is going this way. Yeah, P is correct. So about Q down. Q down. Q up. Salah. So answer is A. So this one equilibrium. You see equilibrium. Answer is A. Okay. Now, diagram 21 shows the mass M sliding down the inclined plane with the resultant force. Now, which of the equation represent the resultant force, right? The resultant force, so you need to label all the force in first, right? And then this theta in. Okay. So, now, the force that bringing it downward here is W, right? W or mg. You bring to here. Touch or not touch 30. Mg. This one is mg, right? Mg. Touch or not touch 30. Touch or not touch theta. Not touching, we use sine. Am I right? So, mg sine theta minus fg. Answer is A. Very fast. Very fast. You don't need to draw triangle. You'll love it after you use my way. I know most of you already learn this one so that you get used to the first method you have used it. So you want to change it sometime like harder. Okay. All right. We continue. This one is T1. So we find T1. So I make it smaller. Now T1. Right. T1. T1 this direction wrong. T2 this direction wrong. T1. Or T1. Yeah, T1 in this direction. T1 in this direction. Okay. T2. T2 and then W. So answer is D. You just follow their direction, equilibrium. So now this one also, this one is T, this one is T, and then this is W, right? Cannot see, Whatever lah, don't care. So this is T, this is T. Alright, so you see T in this direction, okay. In T in this direction, okay. And then W like going down. Yeah, this one is quite okay, but bengkok leh. The W should be going down. So, but this one is 2W. Oh my god. Huh? Oh, this one I haven't do. This is 2W. Not C? Hey, what? 22? Wait. 22 not C? Yeah, sine theta. Why I circle A? Thank you. Thank you. Sorry I repeat Why I circle A? So MG, I don't touch. I use sine. Right? I don't touch, I use sine. Right? Touch, then I use cos. Not touching theta, I use sine. Yeah, you are right. Yeah, correct. I'm wrong. I'm sorry. My mistake. Yeah, thank you. Thank you to correct me. Right? If I am wrong, you correct me lah. No problem. Answer is C. Yeah, correct. Careless mistake. This one like no answer. The best answer I think still A. Still A. T1, T and then T. This is 30 and 30. So this answer is A. Answer is A. No better answer already. So I choose A. So this one I didn't do. I just cut it and put it in. Negeri Sembilan. We see the answer, Question 21. 2004 2024 Negeri Sembilan. Paper 1. No schema. Oh my god. No answer. Oh, got. 21. 21D. 21 is D. The answer is D. Oh my god. Cannot. I don't agree at all. No way to be this way. T1. T2. Wrong. Where got correct? This one is wrong. I put into this way because of this one is supposed to be like that. Okay, never mind. Okay. Where? It's supposed to be this way. Okay. I turn. Cannot turn. Only can 90 degree. Rotate a little bit, cannot. So it's supposed to be W is going down. This one is going this way. This one is going this way. Their direction all correct, right? But just not so right to go down only. Other will be okay. So I put the answer as A. Okay, I put the answer as A. That is a box in stationary on the inclined plane. So this is R, this is W. Okay, they label all the force already. So here it is a angle of 40. Right, this is 40 degree. So they ask you to label all the force. They do which one is represent the free body diagram for this one. W that is going down. W going down. This one up, salah. Out. So FR. This one wrong. So these two out. CD out. R this way. arrow this way, arrow this way. Right? This one and this one both are correct, but the triangle both are correct. Huh? Got two lot ah. Oh yeah, one lot and two lot. Yeah, should be 2W. Later I come back. I do this one first. So these both are correct. So we need to draw the 40 degree. Alright. So the angle 40. So where should we do? This is W. Right. So this is R. This is F. So now, so you look for the 40 degree. Right. 40 degree. 40 degree is in between W and R. Right. In between W and R. 40. This is the direction here. This is 40. So if this one is 40, mean this one is 90, mean this one is supposed to be 50. So here is W, here is R, so this one is 40. So this one 40 degree, mean this one is 40 degree. 40, 40. So this one is the answer. Answer is B. Answer is B. I repeat one more time. I repeat this one. So this is W, this is R, this is F. So the angle here is 40. It's in between R and W. R and W. So meaning that this one is 40. This one is 40, mean here it is 40. Right? So answer is B. So this one 40 is wrong. This one should be 50. Right? Because of this R here is this direction. So here is 40. When this one is 40, so this one 90. 90 minus 40. This one's supposed to be 50. Alright, salah. So I check back. What you say is 2W. Oh, 2W. So this is W, this is W. Okay. Alright, I get you. So this is 2W. The answer is D. 2W. So now I draw the answer first. I draw T, okay. This is T. Now this one is also wrong. This T, yeah, this T. This is 2W. Yeah, answer is C. Answer is C. Answers should be C. Right. T, this T. This angle also wrong. This one's supposed to be 60. This one is 60. Right. No answer. So bad the question. Supposed to be 60. Why? Because this angle is 30. This angle is 30. T to horizontal. T to horizontal is 30. So this angle is 30 already. So this one's supposed to be 30. How? This one, no answer. The answer given is this one, right? This one also wrong. 60. Oh, I know already. Their direction is T. You cannot see it from here. Normally, we'll draw the direction exactly same as what they have. Okay. Now, never mind. I am going to screenshot this one. I try. T. Never mind. Okay, we see. We check it from here. Wrong. T, T, 2W. The answer is like that. So, this one no answer. No answer. C very close already, but still not the answer. The answer given is D. Right, this one we see. So this one no answer. Bad answer. Answer given it is C. D. But D I am not agree. D I am not agree. So cannot. Cannot. Alright. So we continue from here. Alright, question number 22. Which relationship it is correct? Okay. So you label all the forces in first. This one, here it is theta. Okay, here is theta. Cannot see. Yeah, this one is theta. So the rest, the object is at rest. So meaning that the force that going up, going up is equals to down. R is equals to W touch theta. W cos theta. So R is equal to W cos theta. R is equal to W sin theta. Salah. Both are wrong. Okay. So we see here, this one is not moving, mean this force and this force it is the same. So W will bring down to here. W not touching theta, sin theta. Right? F is equal to W sin theta. F is equal to W sin theta. Yeah, answer is D. Okay, not. Okay. So diagram show Jonathan pushes a snow sled. Which of the direction it is Fx and Fy or an F? So F is like that. So this one you can resolute it into two direction. So one go to here. So one go to horizontal, one to vertical, right? So this is Fx, this is Fy. So Fx so Fx and Fy. Fy is going down, yeah. Fy is going down. X is wrong. Should be go to the right. Okay. Fy going up, salah. Fy going down. Fx go to the right. So answer is D. You go to here, mean you resolute it to here and here. Right, two direction. Okay. The balance force, we seldom say balance force, but balance force it is called equilibrium also. Acting on the object will cause the object continue to moving with constant velocity, but they never said, I don't know whether constant velocity or not. I put a question mark here. Right? If you said continue moving with constant velocity, yeah, okay. Deceleration, no. Number 2 is wrong. Number 2 is wrong. Moving with uniform velocity, continue to move with constant velocity, 1 and 3 together, then it's correct. Answer is D. Okay. Now, T and T, right? T bring to here, right? You see, T not touching 50, sine 15 plus T sine 15 is equals to the weight. Weight is 10 Newton. So T is 10 divided by sine 50 times 2. Right? So 10 divided by 2 divided by sine 15. That's my answer. 19.3. You see 19.3. Answer is C. T is equal to 19.3. Answer is C. Can? Whereas I explained a bit. T not touching 50. T not touching 50 is equals to the weight, which is 10 Newton. T sine 15 plus T sine 15 is equals to the weight, 10. I don't believe, Eldon, you can do triangle and do faster than me. I don't believe. Can? You draw triangle and then do faster than me? I don't believe. You believe? I don't believe. Because of you, when you draw triangle, no lah, a lot of work. That's why I ask you to do it this way. 我真的打死都不信，因为试过很多次了。以前我也是教 ，last time I also use triangle to teach, but when I don't use triangle to teach, because of this one is my Form 6 teacher, maths teacher taught us one. My Form 6, maths teacher. Form 6 is like they are like more complicated one. Many forces act into different direction. Use triangle cannot one. After Form 6 one, then I use this one. So I use my Form 6 one, then I don't want to use back this one already. So hard. I feel like it is hard. Diagram 9 shows two weights suspended and on a rope that pass through a pulley. Alright, so you got a weight here. You got a weight here. Okay, they ask you what is the tension. So no way, you have to do all the equation out. So this one is heavier, is going down. This one is going up. Okay, so we label all the force. So this is W. W is 49.05 Newton. 2.5. 2.5 times 9.81 is equals to 24.525. 24.525 Newton. Okay, so here it is tension. Here it is tension. So this one x-ray upward, this one x-ray downward. Okay, so now I am going to do this one first. All right, first equation, and then after that this one. Right, I do two equation. So first equation is going down. 49.05 minus T is equals to 5A. I got the first equation. Second equation is going upward. T minus 24.252 is equals to 2.5A. So we solve them. So this one minus this one is minus 49.05 left, negative. Right? A time negative. Then gone. Okay. So divide by 7.5. Divide by 7.5 is your A. But they don't ask you to find A. So A is equal to 3.27. So after that, you need to substitute back into here. Your T gonna be 2.5 times 3.27 plus 24.525. So this one times 2.5 plus 24.525. Okay, you got 32.7, 33 lah. 24.525. 0.7. Why, teacher, why this one like 33? Because of in between they round off here. The step on the top one, 24. Oh, 525. Okay. Sorry. Thank you. But I didn't do anything wrong. My answer is still correct. Because of I pressed the calculator, I didn't follow. I just time negative. I normally do it that way. Thank you. 32.7 newtons. So 33 answer is B. Why you are having 33? So I show you. I show you why. Okay. So 49.05 minus 24.525. So sometime after here they round off 44.5. Okay. You see 44.5. Sorry. No. 49.05 minus 24.525. You get this one, right? So, and then divide by 7.5. You get 3.27, right? 3.27, So, like, sometimes they will like round off to 3.3, right? 2.5 times 3.3 plus 24.525. They will like, it's still, they round off a lot. They round off a lot. Because this one and this one is very far. Or they use the gravity as 10. Maybe they use gravity as 10. I try. This one is 10. So 50 minus 25. Left 25 is equal to divide 7.5. 3.33. The acceleration is 3.33. 3.33 times 2.5 plus 24.525. They use G as 10. Some teacher, they will use G as 10. Very near to 33. Okay. Time's up already. So I give you some question. You try to do it at home. Your homework. This one is your homework. So your homework is from page. I try to discuss because this kind of question they normally repeated one. So you practice more, then you get better. A lot of. Maybe next week we'll try to do some structural question. Objective, you try to do it, and a lot, really a lot. Wow, I tell you, really a lot. Until 1.0. So next lesson, I try to do as much as we can using structure. So you try to do it from page 66 until 110. Page 66 until 110. I told you you use my notes is enough already. Page homework. Wow. Page 66 until 110. Okay. Okay. So any other question? So next week we are going to do exercise. So after that we are going to go to elasticity. Right. Here a lot of exercise. You try to do it first. If you can finish, then you try to pass it up to me. Then I will see lah. I will check for you or not. I can, then I check for you. Is that okay? If okay, then I am going to stop here. I'll see you next week. All right. Bye bye. Don't forget to help me to press the like button. Thank you. Press the like button. Thank you. Bye bye. Good night. Bye bye.